Hi, welcome to this Algebra 2 quick tutorial on simplifying roots and fractional exponents. This tutorial is kind of geared towards the Delta Math assignment that you have coming up. There are also some more involved videos attached to those Delta Math activities. So first I'm going to start with simplifying basic cube roots. And our first example is going to be the cube root of 8. And you might look at that and say right away, well, that's going to be 2. Reason being, of course, that 2 cubed is equal to 8. So that's a simple example just to get us started. A trickier one would be the cube root of 16. If you ask a calculator to give you the cube root of 16, it's going to give you a nasty, irrational, long decimal. And that's not really the goal of simplifying a cube root, which is to say that the cube root of 16 is ick. However, when we can think about the cube root of 16 is that it's the cube root of 8 times 2. And 8 is a factor of 16 that is itself a perfect cube. And when you're thinking about questions like this, it's useful to have in mind some of the first perfect cubes. So we know we can look at the 16 and say, well, is any of these numbers a factor of 16? And if one of them is, you can rewrite it like this: the cube root of this perfect cube, 8 times 2. And at that point, we can take the cube root of that 8 out of the radical. So this becomes 2 times the cube root of 2. So to make this abundantly clear, I just want to point out that this 8 that was a factor of 16, when I simplify this radical, it comes outside. It doesn't come outside as 8, it comes outside as the cube root of 8, or 2. So 2 cubed. We've simplified the radical. We've gotten it down. The number that's inside the radical is as small as it possibly can be. So quickly, just one more example. Cube root of 56. Stop and think. Is there any factor of 56 that's a perfect cube? Maybe there is. So cube root of 7 times 8. 7 times 8 is 56. Oh, nice. 8 is a perfect cube, so I can rewrite that as 2, which is the cube root of 8, times the cube root of 7. And so that has been simplified. Lastly, you're going to see some examples like this last one, which looks scarier than they actually are. So what you want to do is think of this as cube root of something. So you have m to the 7th. Well, m to the 6th would be something that we could actually take the cube root of, because m to the 6th is really m squared cubed. So the cube root of m to the 6th is m squared. And remember, the inside of this radical was m to the 7th, so it's actually m to the 6th times m. So the cube root of m to the 6th times m is the same thing as the cube root of m to the 7th. And the cube root of m to the 6th is m squared. So this becomes m squared times the cube root of m. Now we have some simplification exercises involving fractional exponents. And our first example is 16 raised to the 1/3 power, which, as you should know, means that this is going to be the cube root of 16. So then we can follow the procedure that we were using before. This becomes cube root of 8 times 2. 8 is a perfect cube, so we finally get 2 cube root of 2. The next example is combining with this exponent of 3/4. We're getting a couple of different possible ways of looking at this. One of them is that we have, because the over 4 in the exponent, this becomes the 4th root of 3 cubed, which is the 4th root of 27. And that's as far as we can go with that. Now we could take an alternative approach here, which is to say, reverse the order in which we do these things. We could take the 4th root of 3 and cube that. But I think that's kind of worse because there's nothing you can do to simplify the fourth root of 3, and then putting all of that inside parentheses and cubing it is not as simple as this one right here. So you can try alternative approaches, but pick the one that is the simplest when you're done. Okay, now we've got another example here, which is 4 cubed taken to the 1/2 power. And of course, that would be the same thing as 4 to the 3/2, because if you have the exponent of something raised to an exponent, you multiply the exponents together. And that again leads us to 2 separate approaches that we could be taking. The square root of 4 cubed, which is the square root of 64, and the square root of 64 is 8. So that's nice. The alternative approach would be to say that this is the square root of 4 raised to the 3rd power, which becomes, well, the square root of 4 is 2, and that's cubed, which of course is 8 again. Now we're on to simplifying nth root radicals, which sounds pretty horrible, but in this case it's not going to be too bad. So I have the 5th root of p to the 5th. Well, that would actually be p to the 5/5 power, which is the p to the 1st power, which is just p. Put that right away and said the 5th root of p to the 5th should just be p. Quite simple. Now, second one, we have the 5th root of p to the 10th power. So that would be the same thing as p to the 10/5 power, which would be the same as p squared, and that would be as good as you get. Finally, if you get some kind of a combination like this, you can actually break it into 2 separate problems that are multiplied together. This is the 5th root of 32 times the 5th root of p to the 10. And the 5th root of 32 is, in fact, 2. So this becomes 2 times p squared, because we already did actually this piece up here. So break it into smaller pieces like this if you need to. And that's it for today.